Hi everyone, thanks for joining our session. Our paper is titled Data Streaming Processing in Reconciliation Testing, Industrial Experience. Um, the paper was authored by a group of people working at Exactpro. The names and titles can be seen on the slide. My name is Alexey Yermolayev, and today I'm going to present our research with my colleague, Nikolay Dorofeev. Um, The structure of today's presentation reflects the paper contents. Uh, First, we will touch upon the importance of data reconciliation concept for the task of software testing. As part of the literature overview, we will discuss existing approaches to data reconciliation and data stream processing. In order to provide a business context, we will discuss how the data reconciliation task was solved at Exactpro in the first generation of the test automation tool suite. Then we will share the industrial experience around the data streaming analysis for the task of the reconciliation testing and describe the solutions created at Exactpro. We will outline advantages and disadvantages of the approach and compare it to existing state-of-the-art data processing solutions. At the very end of our presentation, we will share the lessons learned and answer the questions from audience. Data reconciliation is usually defined as the task of matching records associated with the same entity but represented in different datasets. This task is typical for the systems dealing with data flows transferred between multiple components of complex platform. In financial technology, data reconciliation is crucial for market data dissemination. Electronic trading, clearing and settlement, and other areas of financial technology that involved matching data received from different channels or via different protocols. Um, So complexity of IT systems increases dramatically from day to day. On this slide, you can see a typical exchange system. Different system components use some fractions of initial data. So to ensure correctness of the data involved in cross-component interactions, a lot of reconciliation checks are required. But complexity, it's not the only challenge. Processing power rapidly increases, and financial platforms are required to process bigger data volumes and process them at faster pace. Um, these trends create a new requirements for the data reconciliation approach. When it comes to complex financial systems, it cannot be simple field matching task. Such an approach needs to satisfy not only the data accuracy requirement, but also be suitable for the rule-based processing of large volumes of real-time data. This industrial need can be addressed by the stream processing paradigm that shifted the task from querying stationary data towards dynamic queries against real-time data. So let's look closer at the approaches to data reconciliation. Our literature overview has shown that there are several parameters differentiating them. One of them is data model. It defines the type of the data we use. It can be either persistent or continuously changing. Another parameter is data format. It describes the form of representation of database items. It can be tuples, objects, or XML structures, anything from text, strings, or numeric values to graph representations. Next parameter is the matching type. In different research papers, we have found the following examples. The most straightforward is exact matching, typical for the task of the data consistency accuracy checks or finding duplicates. Recursive field matching, represented by several matching patterns between data strings and substrings. And approximate matching, similarity of the data rather than exact match, mathematical approximations, and machine learning techniques. And the last but not least parameter is the matching procedure, which defines the type of the requests. It can be either streaming SQL queries or custom API requests running against custom data structures. Real-time data processing shifts from traditional database management system towards to new generation of tools called information flow processing systems. There are two types of stream processing solutions on the market, stream data integration and stream analytics. The first type of tools provides a lot of APIs, producer API, consumer API, connect API, which allows us to connect stream producers and stream consumers according to our needs. The second type is stream analytics, is represented by the solutions that process the data, applying certain user-defined algorithms. Rule-based analysis and reconciliation of real-time or near real-time data are quite heavily researched and implemented in the present-day tools. All of them create a very diverse external and industrial context for our streaming data reconciliation task. However, this context cannot be considered fully outlined without the preceding experience with internal software implementations related to the task. So some of our tools are on the slide. Shusha is the post-transactional passive testing tool for testing the backend of trading platforms and interaction between trading systems. It's also applicable for audit and certification. The tool uses fixed data model. Data format consists of database objects, exact and recursive field matching types based on SQL queries requests. TVR is a passive testing tool which allows to verify results obtained during both functional and non-functional test executions. The main purpose of is trading logic and consistency in all the flows. The tool uses a fixed data model, but data format could be different because it applies all data formats described in this research for different aims. Exact and recursive field matching types based on programmatic queries requests. The next one, MD Analyzer / book checker. This is a tool for building instrument books based on persistent data and reconciling it with programmatic queries requests. Book checker uses tuple data format in combination with exact matching type. NFA Analyzer sorry. reconciles parameter from already stored different API flows, use XML documents for reporting. Exact and recursive field matching types could be configured with programmatic queries requests. And the last one that's shown on the slide, Mini Robots, is the first stream data model testing tool. It could simulate real traders' behavior based on programmatic instructions. Object-oriented data format correlates with all the matching types described above. So all listed tools, except one, perform reconciliation. They are different and intended for different aims. They have variable configs and variable logic. But one thing is common. They have passive architecture. The complexity of the systems increases dramatically. At the same time, business requirements couldn't afford to spend huge amount of time for testing. So real-time processing becomes the key idea on the market. With the bigger complexity of the systems under test, QA tools should provide a lot of flexibility in verifications and configuration. Based on these points, some time ago, we have started to develop a new testing module called Check to Recon.
To address multiple challenges and improve functionality range and the performance of test automation, Exactpro team created Teach2, a Kubernetes-based microservices toolkit for testing complex distributed transactional systems. Teach2 is a modular solution with testing components running within Docker containers. Check2Recon is one of these components. Check2Recon box consumes several event streams, compares messages in order to detect discrepancies in the data. In addition, Check2Recon can mark up the messages with notes signaling about potential problems. Before use, Check2Recon should be configured according to our purposes. We remember that Teach2 box is also a Kubernetes pod, so the pod's config contains some technical information such as a maximum number of stored events, cache size, and event sizing interval. The core of the data reconciliation functionality of the described solution is implemented through the concept of rules. Rules are special Python classes that contain the logic of comparing events. Rules need to be defined both on the pod level and as Python code. The working principle behind this class is as follows. For each rule, the getters associated with the rule name, description, and other attributes to be displayed in the GUI. Message groups to compare are described in a corresponding special getters, allowing you to define a group name and its type. At the moment, there are two group types. The type single means that messages in the group are allowed to have unique hashes only. All messages with duplicated hashes will be deleted. The type multiple means that the group can store several messages with the same hash. The group, hash, and check methods in the rule class are responsible for message processing, which is performed sequentially from a group to hash to check for each and every incoming message. The group method analyzes a message using an algorithm written by the user and sets the message group ID for the algorithm to be able to allocate the message to an appropriate group. The hash method generates the hash key for the message to be processed by the join-like query. The hash key is like a composite key in SQL databases and depends on one or several fields of the message. If values in all these fields from one message are equal to corresponding fields from another message, the final hash keys of such messages will also be the same. The check method is used to compare a given message with all messages from different groups having the same hash key. By its nature, the underlying programmatic query is not very different from SQL-like joins. After the comparison, the check method generates an event with a comparison result, depending on the logic defined by the user. After that, the original message is available for comparison with upcoming messages until it's deleted after timeout. Our industrial experience and shows an attempt to include a data reconciliation model into a complex microservices-based architecture of a bigger test automation framework. The Check2Recon module supports both persistent and streaming data models, as the Teach2 framework allows the testing systems to read the stored system flows data. For better fault tolerance, it would be great to use hybrid approach. When the message flow is too big to be processed in real time, the tool could start storing the unprocessed messages above the queue and continue analysis with a minor delay. Further, when the message flow becomes weaker, it could get back to real-time streaming analysis again. The tool allows for the data format to be highly customizable. Teach2 is designed to store and process the data in a unified format, even if original protocols of data flows are different. The matching type used in the module for data reconciliation is completely configurable by rules, classes written by the user. we could configure several rules to work at the same time. As for the matching procedure, we followed the programmatic approach, developing a custom API for advanced processing based on user-defined logic. At the same time, the approach under the hood of the Chectorecon has ideas similar to SQL-like query structures. For example, hash is used as a composite key for message identification and search like a primary key, and two messages are matched if the hashes are equal, like in joins. Commenting on the implementation of the module, the choice of Python as programming language underpinning the solution has both advantages and drawbacks. On the plus side, the implementation benefits from simplicity and flexibility. It is also easy to use due to Python's popularity at a relatively low entry threshold, which is an important detail from the perspective of a user. The disadvantages of the implementation include limitation of using it in a single-threaded mode only and relatively low performance. This model was developed as a proof of concept for streaming analysis via Teach2, and it served this purpose well. Chectorecon provides advanced rule-based reconciliation capability suitable for working with continuous message flows. Comparison of the tool with most present-day applications for data stream analysis shows that it is not the most efficient implementation of the cancellation testing approach, but still it works well. All in all, we came to the conclusion that our primary aims are achieved. The idea of Chectorecon contributes to the development of software testing professional domain. Secondly, our contribution here is provided by outlining the lesson learned from the comparison of this custom-made component against existing tools. And finally, this experience will help to improve data reconciliation tool. Thanks for everyone. Now we are ready to answer your questions.